Hello friends, here the operating system, lecture number 2, topic system calls. A system call is a way for programs to interact with the operating system. System calls is already a program which is used to interact with operating system. Dual mode of operation. In system call there are two types of modes, user mode and kernel mode or supervised or privileged mode we can call it. For user mode there is a bit 1 mode bit and mode bit 0 for kernel system mode. What is user process? When user process executing. When user give any commands, means want system calls, then when the user is when user is interacting with process, when user are in their PC, then this is in user mode, means mode bit is 1. When the user want to execute any process, means call the system calls, then the mode bit set to be 0. Now your operating system is in supervised or privileged mode. When the task or system calls executed, then they return the mode bit 1, and now the user mode again set. When the system executed, process executed, they returns and update the mode. Now the mode become again user mode. The part of operating system, there is two parts of operating system. First we call kernel, another is shell. Kernel is a core part of operating system where there is a programs or code to use the system. Means there is a programs in kernel there is a core programs of the operating system, means the functions operating system, how the operating system interact with the hardware and many other features functions of the operating system comes in the kernel part. In shell there is a user interaction medium. Shell is a user interaction medium with kernel. In Windows we use a GUI, like there is options to interact with, like we want to open as we right click in desktop, there is a open the options. If we search in search bar, we search something, then it open, means we can access the programs, kernel programs, with the help of GUI, graphic user interface. There is also a CMD command cell where we use commands to access the kernel commands, kernel program in PC. Here the process, what is the process? A running programs called as a process. Means the process is the program with running activities. Program is a set of instruction, means code. When the codes come with runtime activities, means extra things can add in program, like its runtime, when it will execute, when not, and extra resources. With all these things we call it process. Here the process definition and representation. First, here the representation of process means how each process is stored in main memory. We know that when we click on any process, like we open any application, then their programs will load in operating system loaded in main memory. Here is the main memory in which there is operating system and the programs, like if you open browser, then the browser programs load in operating system. If we open text editor, then it will open process 2. Here is a process, means that application or programs running in our system comes in OS. In each process is divided into 4 blocks. First, stack block, heaps, and data structure, and the code part. These 4 blocks, these 2 blocks have fixed size blocks, and these two blocks have variable size. In last coded text section, in this section of memory, there is a program or instruction which is written in low level language, means that there is a program process having a high level program, then converted to the low level and stored in operating system, means that in our main memory. Load in main memory means that there are 4 parts of main process, 4 blocks, code part, and then data section. Here data section, there are global and static variables are saved, and there is a stack and heap. In heap is a part of memory where dynamic allocations, when you have seen, we have used calloc, malloc in C language to allocate dynamic memory. So when dynamic memory allocate, then the heap size increase and decrease. When deallocate the memory, then heap will reduce. Here the stack will use to return the address to save the local variables, functions and parameters are stored in stack. Okay. Here the operations of process create a resource allocation, schedule runs, suspension, termination. These are the operations of the process. Now the attributes of process. The process have process ID, program counters value, GPS general purpose registers, list of device, means that program which device program can access, types of process, size means how much size programs, memory limit from which address to which address memory according to this process, priorities, and state of program process, and list of files which will access by programs. Here the operating system, there is a main memory. In main memory there is operating system. In operating system there is a PCB, means that the number of processes are in main memory. There is a P1, P2 are the process in, and here is a PCB of each process. Each process have PCB, means P1 process have PCB, P2 process have PCB, and P3 process have PCB. In PCB, these attributes are stored. PCB also known as processor descriptor. In PCB, when the process of main memory goes for execution, when P1 process go for execution in CPU, the PCB also load in CPU with the process, and the process comes back in main memory. They comes with updated PCB, means that when the process P1 goes to in CPU, then their PCB's data also goes in CPU. In PCB there is some details, means there is a memory address, size, list of device which will access by processed. These all things are written in PCB. So the CPU can access these data to execute process P1. If we resume the process, means process come back to the main memory, then the updated PCB comes. The PCB should be updated, means that from where to where the process have been executed. So when again P1 come in CPU, so it should not restart it. It should restart from where it resumed. Context. The context of PCB or the process are collectively known as context. Means that in PCB there is these all things are stored, and these things collectively known as context. Context switching means that when P1 process goes in CPU, then their PCB's data also goes in CPU for execution. When P1 process come back to main memory, then their updated PCB comes in OS. Then P1, P2 process goes in CPU, then their PCB datas go in CPU. When the P1 process completed or resumed, they come back to main memory, and their updated PCB comes in OS. Means that there is a context switching. Context switching means when P1 process go and return, then P2 process go and return. Here the context means data of PCB change. Here the when P1 goes, then the P1 PCB data goes. When P2 process go, then PCB process 2 PCB data go. Means that the data of PCB should change when the process is changed. We switch the context or data of the PCB. Dispatcher which perform context switching. Process states, there are some process in when the process they state there are new process, new, ready, running, terminating and waiting and block. There are the 5 states of the process. When the process are in secondary memory, or means if you have installed programs but you are not using them right now, as called these processes are in new state. When you click the process, they comes in ready state. Means that when you click any application, they comes in ready state. Means they loaded in main memory for execution. Okay, from ready state, when there is a CPU free, then this process goes for execution running in CPU. When the process complete execution, then they exit. But between the running, if the process want any event or want any input output device access, if you want to access any device, then the process goes in waiting or blocked state. After blocked state, when the process get input output, then they again back to the ready state, because when the process come here in blocked state, then another process goes in running state in CPU for execution. So the CPU is not free at that time. So after input operation, CPU come to ready state, and when the CPU get free, then the process again go to running state. Here the state is preemption. Preemption means that we already studied that there are 2 types of operating system. They are preemptive and non-preemptive. Preemptive and non-preemptive. In preemptive means that when the process is running in CPU, forcefully the operating system preemption, the process is forcefully get out from CPU to ready state. And there is a definition of all states, and we know new to ready state when the process is admitted to operating system. These are all definition. You can access this PDF from my Telegram channels. So there is link in description. You can access this PDF. So there is another topic, process scheduling. We will cover this topic in next lecture. Thank you.